class, the lesson I'm teaching today is called What Makes a Boat Float. Today we have Daniel helping us out with the lesson. So Daniel, have you ever wondered why certain objects float in water while others sink?
Yes.
Okay, well today we're going to talk about the two different factors that determine whether an object floats or sinks. And these two things are called density and shape. So first we're going to talk about density. Density is the relative weight of an object, or in mathematical terms, density is the mass of the object divided by its volume. So let's talk about more and less dense objects. A more dense object has tightly packed particles, which means that it will sink in water, while a less dense object has more loosely packed particles, which means it will float. So for an example, let's think about a brick and a piece of wood. A brick, for instance, is more dense than water, which means that it would sink, because that also means that the particles in the bricks are more tightly packed. So, what about a piece of wood? A piece of wood is a big material too, right?
Yes.
So do you think that it would float or sink?
Sink.
It could be because that you're thinking that the object is heavy and that it is just as dense as the brick. Although, the object is actually less dense than the brick because the particles are more loosely packed, which means that it's going to float. But speaking of floating, density is related to buoyancy. Buoyancy, which can be thought of as a tendency of an object to float in a liquid, but in other words, a buoyant object will float. So, we can conclude that dense materials are not as buoyant, so they will sink, and buoyant materials are not very dense, so they'll float. So what was the other factor that we said determines whether an object floats or sinks?
Shape.
Shape. So, if we're talking about shape of an object that we are talking about, just like a boat, the shape will allow the object to push water out of the way. Another word of pushing water out of the way is called displacement. So, if a boat displaces or pushes water out of the way, more water out of the way than the weight of the boat, then it will float. Just the opposite is true. If it displaces less water than the weight of the boat, it will sink. We don't want a boat that's going to sink, do we? Okay, so the shape of the boat is actually very crucial to determining how much weight it will hold and whether it's going to sink or float. So its shape strongly influences its buoyancy. What about the height of the boat? Do you think the height of the sides of the boat matters?
Yes.
Okay, well let's practice that. We're going to practice using model clay, and we are going to see whether the shape or the density matters more. So I've got some model clay, and I've made it into a boat, which means that it has a flatter side, a flatter bottom, and higher sides. So let's practice. We may have to show this. I'm going to set the boat right on top of the water, and it looks like the boat is floating, right?
Right.
Okay, so I'm going to take this same amount of clay, I'm not going to change anything, I'm just going to dry it off, and I'm going to ball it up into a ball. So, it's the same amount of clay, right?
Right.
And it'll have the same density, right? Because it's the same amount. Do you think that it's going to float or sink? Because we changed the shape.
Sink.
Sink, let's see. You're right. So obviously we can conclude that the shape is more important than the density of an object. But what about, do you think that it doesn't matter whether it's a big piece of Play-Doh or a small piece, right? As long as the shape is accurate.
Right.
Okay, so let's try with a bigger piece of Play-Doh. So even though this is significantly more Play-Doh than that one, it's still in the shape of a boat. So let's see if that will float or sink. It also floats. But do we think the same is true? If I ball this up, is it going to sink?
Yes.
Let's try. You're right. It does sink. So once again, we can conclude that the shape is more important than the density. Okay. So now we're going to do another activity that's going to challenge us a little. I'm going to give you 3 pieces of aluminum foil that I have cut out that are 15 centimeters by 15 centimeters. And we are going to practice making 3 different types of boats. So you can make them any way you want. You can make them with high sides, low sides, round, however you think. But I want you to do 3 different ones. Okay, so while he's doing that, I'm going to show everyone a chart that I've made that is going to track our progress. So on the chart, I've got it labeled 1 boat, 2 boats, and 3 boats. Before we put it in the water, we're going to describe the boat's shape. We are going to make a prediction of how many pennies that we think this boat will hold, because that's going to be a factor. Once we have the shape of the boat designed, we are going to set it in the water, and we're going to see how many pennies we think that the boat will hold, and what factors we think are important to make it hold more weight. Once we do this, then we're going to practice. Now normally, the lesson calls for doing each boat trials 3 trials, but for today's purposes, we're only going to do it once. And then once we get if we do all 3 trials, we can have the children average the number and see what the average for each boat is and which one holds more and which one holds less. And after we do that, I'm going to take the numbers, or today we're just going to have the 1, and I'm going to make a bar graph. And we're going to label the bar graph and have all the right parts, and then we're going to show which one had more or less on our bar graph. Okay. So how's it going, Daniel? And just so you know, each boat has to float for at least 5 seconds in order for the trial to count. Daniel looks like he's got 2 boats. Can I see what you got so far? So far, he's got a round boat with high sides. Looks like it's got a flat bottom. This one, it doesn't have quite as tightly packed, but it's got high sides and a flat bottom. And he's making his 3rd boat now. Talk me through it. What are you doing with that one?
A large base and short sides.
And short sides, okay. So let's make some predictions. So I'm going to give you your chart. I'm going to have you write all your ideas down. So which one do you want to be boat 1?
That one.
This one? Okay. So when you're done, I want you to describe the boat's shape. Okay. So let me show everyone your boat number 3. And I want you to describe the first boat's shape, 2nd, and 3rd. So for his 3rd one, he has a flat bottom, but lower sides than the other ones. While the others were a little more round. Okay. So flat bottom for your boat 3, and low sides, that's what he wrote. Okay, so boat number 2, he says that he has high sides. And then boat number 3, he says low sides and a round bottom. Okay, so let's make some predictions, Daniel. For your boat number 1, how many pennies do you think it'll hold? You think it'll hold 3 pennies? Mm-hmm. Okay. Now what about number 2? How many pennies do you think this will hold? Do you think this will hold more or less than your first boat?
Less.
You think it'll hold less? Okay. So you think it's going to hold 1. All right. So what about number 3? How do you think this will hold?
1.
You think it'll only hold 1? Okay. Well, let's find out. All right. So let's put your first boat in the water. Make sure you keep it high so that the sides don't go in the water before you get it in there. Okay. All right, Daniel, start putting your pennies in there and count them as you go.
1, 2, 3.
There's your prediction.
4.
Oh, looks like we can do more than our prediction.
5, 6, 7.
Oh, 7 is what gets it. Okay. So, in our first trial with our first boat, it held 6 pennies. Okay, so I'm just going to take this out of the water. I'm going to set it right here. So let's try the second boat. All right, Daniel.
1.
Okay, so there's our prediction.
2.
It holds more than our prediction.
3, 4, 5, 6, 7, 8, 9.
Oh, man.
10.
We thought it would hold
11,
less.
12, 13, 14.
I need more pennies.
15, 16, 17.
Oh.
18, 19, 20, 21.
Oh, 20. So were we right? Would this one hold less than the boat number 1?
No.
It definitely held more, right? All right. So, last try. Let's do our third boat. Okay, so this one we said, how many did you say it would hold?
1,
Just 1. Alright, well it's already holding our prediction.
2, 3, 4, 5, 6, 7, 8, 9, 10.
10. Because it floated for a second before it fell over. So that one held 10. So we didn't come out quite like we expected it, did we?
Mm-mm.
So do you think if we kept doing more trials, it would be about the same numbers?
Yes.
Probably. Because it would still be the same shape. Okay. So now we've done our 3 boats. And we have determined which one held the most. Alright, so what factors seem to matter while we were making our boats?
Shape.
The shape seemed to matter. What about the height of the sides? Did that seem to matter?
Yes.
Because this one had the highest sides, right?
Right.
And that one held the most. But this was what kind of confused us, because this had lower sides, but it held more. What do you think made the difference?
The flat bottom.
The flat bottom. So flat bottom makes it carry more weight. So let's talk about that a little bit. So what type of boat do you think would need wide flat bottoms?
Cargo boat.
Cargo boat. What do cargo boats do?
Carry things.
They carry heavy items to and from. Okay, so what about a boat that has knife-like or pointed bottoms of the boats?
Speedboat.
Speedboats are maybe like a canoe or something like that. Something that would need to, what's that word that we talked about? What is it doing?
Displacing.
It's displacing more water. Okay. So, of the 2 factors determining floating and sinking, which one was more important? Density or shape?
Shape.
Shape, because just like with the Play-Doh, we determined that just because 2 objects may have the same density, it depends on the shape whether it will float or sink. Okay, so with your numbers, let's make our bar graph real quick. So, do we know how to label a bar graph?
Yes.
So we put the title at the top. So I'm going to put what makes a boat float. Okay, and then I'm going to do the X and Y axis. And what are we going to put on the bottom part?
The boat number.
Boat number. Okay, and on the side I'm going to put what?
The number of pennies it held.
Okay, so how many did our boat number 1 hold?
6.
6. So I'm going to label this by 5s. So we're just going to roughly guess boat 1. How many did boat 2?
20.
20. We're all the way up here. Okay, what about boat 3?
10.
10. So this is just a way to go over with teacher help how we can show what numbers we got with our graphs. So this is just an easy way for kids to see which one held more without actually just looking at their chart. Okay, so today we've done a lot. We designed our own boats. We determined what factors matter in a boat to make it carry more weight and float. So let's recap. So what we've learned today. What is the relative weight of an object? We talked about that in the beginning of the lesson.
Density.
Density. Density is the relative weight of an object, or is also to be determined as the mass divided by its volume. We also talked about one other thing that's important.
Shape.
Shape. And the shape seemed to matter more than the density today, didn't it?
Yeah.
Okay. So why is the shape more important to the buoyancy of an object? What word did we use that shape matters?
It displaces.
It displaces. So, in order for an object to float, it needs to displace more water than its weight. All right. Well, I think we've covered everything today. We talked about shape, density, and buoyancy. We made our own boats, and we practiced to see what kind of weight it would hold. So, I want to thank you for being with us today when we looked at our lesson called What Makes a Boat Float. And have a good day.